Before you start complaining, oh no, more proofs, look at what it says. It says coordinate geometry proofs. We know a lot of things with coordinate geometry before. Take a moment, think about some things that you might know. We already know that slope, which we represent with m, is equal to the change in the dependent variable over the change in the independent variable. Now, most commonly, such as in this unit, when we're talking about slope, we're talking about the change in y over the change in x. Another thing that we might remember, so that's slope. Another thing that we might remember is that we have the midpoint formula. And this is the average of the x's, comma, the average of the y's. And this helps us find the halfway point between two coordinates on the coordinate plane. And one last thing that we might remember is the distance formula. And I know this is a long one. The distance formula states that distance equals the square root of the change in x squared plus the change in y squared. And remember that the important thing is that you are paying attention to your x's and your y's, not necessarily that you find the difference between the x's first or the y's first, because addition is commutative. You might be asking yourself, what is a coordinate geometry proof? Well, it's just proving something using what we know about coordinate geometry. So what do I mean by that? Slope, midpoint, and distance, most commonly. So we're going to be starting to look at things on the coordinate plane. So the very first thing that you're going to do is make sure you have a piece of graph paper. So the very first thing that you're going to do to complete a coordinate geometry proof, the first thing you're going to do is graph the given item. So this might be a triangle, it might be a quadrilateral, whatever it is, you're going to graph it. And then you're going to use slope, midpoint, or distance, or maybe a combination of these, to show what is being asked. So I'm going to start with a more basic example that does not actually require step 1. But before I do that, the very last thing that you do after you use the information is you write a conclusion. Because remember, a proof is always explaining something. So you have to explain how you knew something. So you're going to write a conclusion. So here we have an example that says that the coordinates of the vertices of triangle Ken are k, 2, 1, e, 9, 4, and n, 5, 8. Okay, so we'll label that k, e, and n. And because it is a triangle, we are going to connect those vertices. Now, if I was doing this not on the app, I would be using a ruler, but for now. So we have our triangle. So we want to prove that the median from k to en is perpendicular to en. So right there, that tells me a little bit. I want to find, for median, I want to find the midpoint. So I'm going to use the midpoint formula from n to e or e to n. And I want to find perpendicular. That tells me I'm going to need slope. So I graphed it, I identified what I have to do, and now I'm going to use the information that I have to prove whether or not it is perpendicular to en. So, first thing first, and this is really up to you, you get to choose. I always start by finding the midpoint. So, midpoint of en, and we get 9 plus 5 divided by 2, and 4 plus 8 divided by 2. So we get the midpoint is 7, comma 6. So now I'm going to plot this point, 7, 6, on my graph. Now, of course, I didn't use a ruler, so it's not so great. But that's okay. For this example, it works. You will be using a straight edge for it. And now I need to find the slope of both en and k to the midpoint. Let's call it m for midpoint. So let's find the slope of en first. So I know that that is the change in the y values, so 8 minus 4 divided by 5 minus 9. Okay, so I know that 8 minus 4, that's negative 4, that's negative 4 over 4, which is negative 1. Okay, so the slope of en is negative 1. Now remember, for something to be perpendicular, we want the slopes to be negative reciprocals. So let's change colors. The slope of km, we want it to be the negative reciprocal of the slope of en. So I get 1 minus 6 over 2 minus 7, and I get 1 minus 6, negative 5, over negative 5. I get the slope of km to be positive 1, which is exactly what we wanted. They're negative reciprocals, so that means that the two things are perpendicular. So now the last step in this process was to write a conclusion statement. So this does not have to be a long, complex thing. All I have to say is that the median from k to en is perpendicular, perpendicular to en because the slopes are negative reciprocals of each other. That's it. Just how we know that they are perpendicular. Now, of course, these can be more complex. You might be proving that something is a parallelogram or it's a square. We're going to use for that everything that we did in our last unit about proving quadrilaterals. So let's recap. First, you're going to graph and label as necessary. You're going to use slope, midpoint, distance, any combination of these to find information. And then step 3, you're going to write a conclusion. Now, this does not mean that everybody has to do these the same way. You may all, just like in regular proofs, take different approaches. That's okay.